be categorized as acute, right, obtuse, straight, reflex and complete angles, and based on the pairs of angles they are complementary, supplementary, adjacent, linear pair and vertically opposite angles. Now we are going to take a look on the pairs of angles. Can we find any relation between them? Are there any axioms or theorems on them? Let's find out. If adjacent angles are supplementary, they become linear pair of angles. Let's see this in detail. Consider the angles formed when a ray, say OC, stands on a line AB. What are the angles formed at the point O? They are angle AOC, angle BOC and angle AOB. Here we find that angle AOC and angle BOC are adjacent angles. So we can write the equation as angle AOC plus angle BOC equals angle AOB. And since angle AOB is a straight line, that is it's 180 degrees, we can write the equation as angle AOC plus angle BOC equals 180 degrees. Now this can be mentioned as an axiom, that is, if a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degrees. This axiom can also be written in the reverse manner, that is, if the sum of two adjacent angles is equal to 180 degree, then a ray stands on a line. Now, the statement A is called the converse of this axiom. To check the truth of this statement, let's try to prove it. Draw adjacent angles of 60 degree and 30 degree. First, draw a ray, say OB. Then, with a protractor, mark a ray OC at 30 degrees anti-clockwise from OB. Repeat the procedure to mark another ray OA which is 60 degrees anti-clockwise from OC. Now, the sum of these two angles are 90 degrees. It is not 180 degrees. So, as per the statement, the ray should not stand on the straight line. Here, considering the ray as OC, we need to check whether the non-common arms OB and OA form a straight line. That can be confirmed by using your ruler. We can see that OA and OB do not form a straight line. Thus, the ray do not stand on a straight line. Now, let's check other pairs of adjacent angles. We had drawn the adjacent angles 80 degree and 60 degree, 70 degree and 150 degree and 125 degree and 55 degree. The sum of each pair of adjacent angles are 140 degrees, 220 degrees and 180 degrees respectively. Checking for straight line with the ruler, we find that the one with the sum of adjacent angles 180 degrees is having a straight line which is formed by the non-common arms of adjacent angles, which implies that if the sum of two adjacent angles is 180 degrees, then a ray stands on a line. Hence, we have proved the statement A. Since the statement A is true, we can write it as the second axiom of linear pairs of angles. That is, if the sum of two adjacent angles is 180 degrees, then their non-common arms of the angles form a line. Since these two axioms involves linear pair of angles, they together form the linear pair axiom. So, this is all about adjacent angles and linear pair of angles. Now, what about vertically opposite angles? It is formed when two lines intersect each other to form two pairs of vertically opposite angles. Now, have you noticed that the vertically opposite angles are equal to each other? Here, angle AOD equals angle BOC and angle AOC equals angle BOD. And there is already a theorem stating this. That is, if two lines intersect each other, then the vertically opposite angles are equal. Let's see its proof. In the statement above, it is given that two lines intersect each other. So, let AB and CD be two lines intersecting at O. They lead to two pairs of vertically opposite angles, namely angles AOC and BOD and angles AOD and BOC. We need to prove that angle AOC equals angle BOD and angle AOD equals angle BOC. Now, if we take a close look, ray OA stands on line CD. Using the linear pair axiom, we can write angle AOC plus angle AOD equals 180 degree, which is equation 1. Similarly, as ray OD stands on line AB, we can write as angle AOD plus angle BOD equals 180 degree, which is equation 2. Since the RHS of the equations 1 and 2 are equal, we can equate their LHS, that is angle AOC plus angle AOD equals angle AOD plus angle BOD, which implies that angle AOC equals angle BOD. Similarly, it can be proved that angle AOD equals angle BOC. Now, let's work out a few problems related to linear pair of angles and vertically opposite angles. In the figure, AOB is a line. Angle AOC equals 3x and angle BOC equals 2x. Find the value of x. According to the axiom of linear pairs of angle, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees. Here, OC is the ray on the straight line AOB. So, angle AOC plus angle BOC equals 180 degrees. Consider it as equation 1. Given angle AOC equals 3x and angle BOC equals 2x, substituting the above values in equation 1, we get 3x plus 2x equals 180 degrees, which implies that 5x equals 180 degrees. So, x equals 180 by 5, that is 36 degrees. Now, let's see the next problem. In the figure, two straight lines AB and CD intersect at O. If angle AOE equals 60 degrees, then find A, B and C. Since AB and CD intersect at O, the vertically opposite angles, angle AOC and angle BOD are equal. So, A equals 4B. Let's consider this as equation 1. Since CD is a straight line, 2C plus A equals 180 degree, which is equation 2. Also, 4B plus 60 degree plus B equals 180 degrees, which implies that 5B equals 180 minus 60, which is equal to 120 degrees. So, B equals 120 by 5, which is equal to 24 degrees. Now, substituting the value of B in equation 1, we get A equals 4 into 24, which is 96 degrees. And substituting the value of A in equation 2, we get 2C plus 96 equals 180, which implies that 2C equals 180 minus 96, that is 84 degrees. So, C equals 84 by 2, which is equal to 42 degrees. Hence, A equals 96 degrees, B equals 24 degrees and C equals 42 degrees. So, we can conclude that from the types of angles, we have found an axiom with its converse and a theorem. The axiom is, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. Its converse is, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. And the theorem is, if two lines intersect each other, then the vertically opposite angles are equal.